Okay, YouTube, my name is James PFP. This is I guess a viewer question, like a response for a viewer question. Viewer asked me, is it possible to tell whether or not one voice, like in an audio clip, is the same as some other voice in some other audio clip? And I know that it's possible to do so using some of the software that I use, and I made proviso in the comment where this request was made. Like, I don't know whether or not I can prove definitively one thing or the other. If there's reason to doubt it, I'll make a video. Here's a video. I've got a real cool video playing though, so this shouldn't be too long. It should be interesting to listen to. So let's get right to it. I'm not going to get into any details about who is who. We just use, if we will, like generic names. Voice 1 on the top here, voice 2 on the bottom. So what we've got is a short audio clip with someone talking in the top, a short audio clip with someone talking in the bottom. Let's listen to them both one at a time. Just before, and I'll also say that before we get too deeply into this, that I made a noise reduction pass on these two top clips. There's a third clip waiting below. But these two top clips have had a noise reduction pass. That's the only thing I've done to change the audio from the source that was linked to me.
She asked me for that. She said, I'll go get you more later. You know, we were going shopping Saturday morning, and she had plans with her best friend.
The reason why I've used this clip offset to this other clip is because of the word here.
Going shopping Saturday morning.
Okay? That's what I'm using as a synchronization point, sort of. And we'll see why when we listen to the next clip.
Accountable for their behavior, to make people look at themselves and stop what she believed to be unfair. I don't think she worried a lot about it. She had a real radar for that.
So, the reason why I've offset it is because in both clips there's a moment in time where the voices, if they're similar at all, are at their most similar, right?
We're going shopping Saturday morning, and she had plans with her best friend.
So what I've done is I've used one of the features here in Audacity, which you won't be able to see because of the way that this doesn't catch certain types of overlay. But if I go under the Analyze menu here, the second option I have is Plot Spectrum. So what I did was I took a section of audio from this clip on either side of that stop moment. It's like 3 seconds long. And I did an analysis of that 3-second clip. And then right below it, I took another 3-second clip. Like that. And did a similar analysis. And let the thing render. Took a screenshot of both of them. And now we'll look at the screenshots. So, the screenshots. We have voice 1, this is the one we're looking at here now. I can, of course I could zoom in on this a good deal. And I think if I crop to this part of the image, this will be the same for every other image in the series that is here coming. Normally only necessary to look at this first little bit of the image. I can zoom out if necessary. Like we can just do this, I guess. That should be showing up fine here. Yes, okay. That's the first one. Here's the second one. So voice 1, voice 2. And in my opinion, if I had to put it in like the way it sounded to me, because I didn't give my opinion before we got to this, I did think that the voice 2 was slightly deeper than the top voice. Like the higher voice is voice 1, the slightly deeper voice is voice 2. But the clip, I made sure that I'm going to prove it here now, right in front of your eyes. The clip does have a section where she talks lower,
themselves.
You know, we were
and
going
stop
shopping Saturday
what she
morning,
believed to
and
be-
and a clip where she talks higher.
I don't think she worried a lot about it. She had
So the clip that I've got selected right now is 4 seconds. I'm going to prove it right in front of you. I'm probably going to have to undo a thing here in GIMP as well. Undo item visibility, undo crop. Okay. Analyze plot spectrum. You can't see this window that just popped up. I'm taking a screenshot. I'll drag that image into the GIMP. Bring out the GIMP. This is hereby Voice 2B. So Voice 2B is related to Voice 2 in that it's slightly deeper again. But otherwise, there's a difference in the quality of the voice from one point to the other. If you get me. And either way, there's a huge difference between Voice 1 and Voice 2. Right? So, I'm going to get rid of that Voice 2B layer. I just did that right in front of you to prove that I'm not trying to fudge the images or whatever. There will be different graphs each time. But there is a definite way of looking at the graph where you can see one voice is higher pitched because there's a higher range at the top, whereas the other voice is lower pitched because there's a lower, or like a more even range. And if you had a really low voice, you'd expect the graph to go up again because there's not much top end. The reason why I have 3 clips is I was curious about whether or not I could fake it, essentially. So what I did was, I haven't muted these, I need to mute them. What I did was, I recorded my own voice. And to see whether or not I could trick it, essentially, I'm going to just play the clip that I recorded. Okay, we got to do a test. And I'm going to test my own voice against this software. First, regular voice. This is the regular voice test. Next, we will do a Debo voice test. This is the Kissinger voice test. Everything will be fine once the voice test is done. And then we got to do a third voice. The third voice is the Julie baby. Please don't go. Julie, don't go. Okay, so that's done playing. That's all we need to think about. I took a similar set of samples from each of those. And now I will present to you what these look like. Just as a comparison. Crop the selection so I can zoom in. And look at this way. This is my own voice, normal voice test. This is my own voice, Kissinger style. Very little difference. You can see at some points that the graph is basically the same. There's a slight shift perhaps from one range to another, but other than that, it's practically the same. You know, that's my voice against Voice 2. And then my voice against Julie Baby. That's the weirdest thing of all. Against the falsetto, there's a little bump here, but otherwise the falsetto is only filling out this range and everything else stays practically the same. So against Kissinger. Julie Baby against Kissinger. So I got curious. If you can see here on the window, algorithm Cepstrum. When you do audio analysis using Audacity, and you do a spectrum analysis with the window type here, says here frequency analysis. There's different algorithms for different situations. And for the voice identification situation, you use Cepstrum. I got curious, is exactly how does Cepstrum work? Oh, wow, wow, wow. I didn't have that turned on. Sorry, my bad. I'll go over that again. This is my voice. This is my voice here. Next, we're going to see against the voice which is selected there now. That's Kissinger. And as I said before, practically the same. The levels have only gone slightly deeper. And against Julie Baby. My voice against Julie Baby, the levels have practically stayed the same. How could that be? How could that be when you can see there's a difference in the waveforms? I'll show you why, because of this window type, this algorithm type, Cepstrum. Aha, it was hidden behind what we were looking at before, right? Why don't they look the same? Against Kissinger. So that's my voice, Kissinger, Julie Baby. So why? As I said in the window there, Cepstrum. That's the type that's used for voice analysis to see whether or not you can tell there's a voice similarity or difference. So there'd be a percent similarity or difference if I was checking these samples mathematically using, like, not even comparing the graphs visually. How does Cepstrum work? Technical math geek talk. Calculus required, Fourier fast transforms. I don't know how to do them by hand. I do understand how they work because I use the software. So I used FFTs in a bunch of different situations. This is a really neat one because it uses a Fourier transform, which is an inverse transform, a square inverse transform on a Fourier transform of the signal at an earlier point. So with a logarithmic table applied in between. Whew, I love it. I understand the concepts. I don't know how to do it with my own, pencil and paper. The long and the short of it is, the Cepstrum type considers the bandwidth of the different frequency bands in the voice pattern here. So if you can see the width of the band here and here is what's pushing that graph deeper. It only needs to see a number of these patterns to take it cuts it up into little tiny chunks and then does a whole bunch of pattern analysis on those tiny chunks. The longer the sample that you give it, the more it's only going to get the same information in lots of tiny chunks. So it just compares them all, and sometimes it gets really cool additively. But the banding, the width of the banding is what gives it away. And if you see here, why is it that the first voice and the last voice have so much in common? When we zoom out on it, I got to zoom in on it again. The first voice and the last voice don't seem to have any of the same banding at all. But if you see how the voice drops at the end, it's because the sample gets as low as it does it sets the baseline, I think. So I kind of gave it away when at the end of the sample. You can hear me do it. Oh, wait now. Unmute.
And then we gotta do a third voice. The third voice is the Julie Baby. Please don't go! Julie, don't go!
At the end. That's what pushed it down to tell the software. And you can see how the banding does shift at that point. So it works well enough, but I think you could probably fake it. However, I don't think you can fake the shift between... I don't think it's possible to fake the shift between the first voice and the second voice in this case. I think that's two different people. I mean, I saw the videos too, well, sort of. I had to download them. But I think that is two different people. Unless the voice has been tonally shifted a great deal. And it is evident to my ears when I'm listening to it. We can listen to it again if you wish. But that's voice 1. That's voice 2. So the difference is that voice 1 is much higher. Voice 2 is much lower. Graphically speaking. Or this is what the graph says once it's like crunched the numbers, so to speak. Oh, wrong one. One last listen to both these and see whether or not you agree with me now. Oh, I messed that up. There's a crash. Woo. Well, yeah, we can go back in time. Listen to it again at the beginning of the video. Thanks for watching. Thanks for questioning Janet. And talk to y'all later.